Well, proteins are like the building blocks of life. So every function in biology kind of depends on proteins. And proteins are specified by what's called their amino acid sequence. And you can think of that a little bit like their genetic sequence, right? So you think of it as a one-dimensional string of beads. And in nature, that scrunches up into a ball, right? But the shape of that ball is very important for telling you what the function of the protein does. So what you really want to know is, can you tell from the amino acid sequence, the one-dimensional sequence, can you directly predict the exquisite 3D structure that the protein will take? And it's been a long-standing grand challenge in biology for 50 years. And of course, there are ways to do this experimentally, but it takes a very long amount of time, very painstaking work on very expensive equipment to just discover, the structure of one protein. And there are, 20,000 proteins in the human body and 200 million in nature. So, these computational methods like AlphaFold really allow you to accelerate that to know the structures of actually every protein in nature. So with AlphaFold 2, essentially we solve the static picture of a protein, the 3D structure of a single protein. That's really important for things like drug discovery or disease understanding. That's why it's such an important breakthrough. But really, biology is a dynamic system. All the interesting things in biology happen when things interact in nature. And so actually, you don't just want the static picture of a protein. You need to understand how it interacts with other proteins, or with DNA or RNA, or chemical compounds like drug compounds. And so that's what AlphaFold 3 is, the first step in that direction of understanding, predicting how pairwise interactions will happen between different biomolecules. The whole point around AlphaFold and why the protein folding problem was so important is that it should accelerate drug discovery a lot and understanding of diseases. And the reason it accelerates drug discovery is that if you know the 3D structure of a protein and you know what its function is, you can design a chemical compound, a drug, to bind to the right part of the protein, the surface of the protein, to block its function or accelerate function or whatever it is that you need to do. So knowing the 3D structure should accelerate drug discovery, but it's only one part of the drug discovery process. So we also need other systems to help with drug discovery, to design the chemical compounds and things like that. So we're working on those topics now. We spun out a new company, Isomorphic Labs, to do the chemistry space of that. And then if that all works, I think in the next 5-10 years, what I hope will happen is, instead of taking an average of 10 years to discover a new drug, which is an enormous amount of time and cost, it can maybe be reduced down to months instead of years, or maybe even weeks, which would be revolutionary if you think about getting a solution to a disease, a cure to a disease in a matter of weeks. That would revolutionize human healthcare.
So I think that's a really beautiful story too that we got in our collection this year. It was to always take a walk, and number 3 was to drink a cup of tea from this teacup.
So I wanted to be inspired not just by the computer science and the engineering ideas, but also the neuroscience and biology ideas of how the brain works. And really that was the beginning of DeepMind, was combining the knowledge from those two fields.
Themes everywhere. So it's a really beautiful tradition we have. And that is a really hard question that I'm not sure that I can answer.
Obviously making some scientific advance that was worthy of something like the Nobel was one of my dreams, for sure, and that's been achieved now. But my overarching dream has always been to build artificial general intelligence, to use it to accelerate human knowledge, so that we better understand the deepest mysteries of the universe around us. I've always been sort of obsessed and intrigued by that from the very, from when I can remember. All the biggest questions: the nature of consciousness, nature of time, fabric of reality. And I think having a tool like AI will help us as humanity understand ourselves better and our place in the universe better.
can see.
Yeah, I can probably play you quickly after my last interview.